We are now ready to start a series of videos that are going to deal with solving exponential and logarithmic equations. The first strategy that we're going to look at, we will look at in this video, and it's called using like bases to solve. Using like bases to solve involves a premise that if b to the m equals b to the n, then m must equal n. This actually makes sense if you think of it numerically. If I have 2 to the 5th power equals 2 to the x power, 2 to the 5th is 32. It can only equal 32, which is another 2 to the 5th. Therefore, the 5 and the x must be equal. This is the premise that we use to solve when I write them as a power of the same base. Now, this is the process. I rewrite the equation in the form b to the m equals b to the n. I work at it until I can get it just that simple, and then I say m equals n, and I solve for the variable. Now, I want to stress immediately that this does have a limitation. Not all problems will involve common bases. So this involves developing a little bit of instinct as to knowing when I'm going to be able to use it. So let's take a look at a couple of problems that I can use like bases on. For instance, 5 and 125. I know that 125 is a power of 5, so I know I can use a common base. 5 is the smaller one, so I'm going to leave him alone, and he's to the 3x minus 6. And 125 I want to write as 5 to the 3rd power, 5 cubed. So 5 to the 3x minus 6 equals 5 to the 3rd. The two bases are equal, so their exponents must be equal. So 3x minus 6 must be 3. Since they said minus 6, I say plus 6. That gives me 3x equals 9. Since they said times 3, I say divided by 3. X must have been 3. Can I check these problems? Absolutely, yes I can. 3 times 3 is 9. Okay, and then 9 minus 6 is 3. And then 5 cubed is, in fact, 125. So I do know, beyond the shadow of any doubt, I got the problem right. The answer was 3. Okay? All right, so it does check. Let's go to the next one. I have 8 and 4. I cannot write 8 as a power of 4 or 4 as a power of 8. But I can write them both as a power of 2. 8 is 2 cubed. And so if I put 2 cubed in the place of 8, that's what that's going to look like. 4 is 2 squared, so I put 2 squared in the place of 4. Then I remember my exponential rules. When you raise a power to a power, you multiply the powers. So that's going to be 3 times x plus 2 equals 2 times x plus 3. X minus 3. Okay? Notice I left off my bases this time because I knew I had identical bases. So this would be 3x plus 6, maybe, equals 2x minus 6. I'm going to say minus 2x on both sides. And I'm going to subtract 6 from both sides. I think x is negative 12. Now, I do want to check that because negative 12 sounds kind of weird. Negative 12 plus 2 equals 4 to the negative 12 minus 3. So that would be 8 to the negative 10 equals 4 to the negative 15. Now, here's where, if I have a calculator, and I do, so I'm fixing to use mine, I say 8 to the negative 10th. I get that on my screen, and it's an overflow because it's a big number. And actually, it's a really small number. Then I go 4 to the negative 15. I get the exact same printout. So I quit right there and say I checked it, and it's 100% correct. Now, in my college algebra class, we're not, at the school that I teach, allowed to use graphing calculators. So it might be a little more challenging to check than that, but trust yourself. If you practice it enough, you'll be really good at this.